Agora. Olá, pessoal, boa noite a todos. Tivemos um pequeno problema com o webinar de outrora. Eu vou encaminhar para quem estava no link anterior o novo link da transmissão, para que possam assistir, mas, de antemão, sejam bem-vindos ao nosso webinar, onde vamos falar sobre Sand Control e outras temáticas. Vamos lá, deixa eu mandar o link para o pessoal que estava lá anteriormente acessar. Estarei encaminhando para todos essa nossa nova transmissão ao vivo, para que possamos dar início ao nosso prosseguimento. Os técnicos acontecem. Bom, foi enviado o link anteriormente, então vamos iniciar nossas apresentações. Boa noite a todos, eu me chamo Nicolas, atualmente estou junto com a diretoria dos comitês técnicos na função de auxiliar nas áreas de marketing e comunicação. Hoje, em especial, estamos promovendo um webinar que trará como foco o controle de areia em si, né? Vamos falar um pouco aqui da temática e dos nossos convidados, mas antes de tudo, eu gostaria de salientar esse webinar aberto para todos. Então, se você é membro SPE e conhece alguém que não seja membro, ou você mesmo está nos vendo aqui não é membro, filie-se ao SPE, faça parte também dos nossos comitês técnicos, iremos passar ao longo da transmissão o link para se filiar aos nossos comitês, o link para nossas redes sociais, para que você, caso tenha interesse, conversar da área de poços ou subsídios de comissionamento, que são os nossos outros comitês, também possa vir a participar dos mesmos e participar das nossas atividades, né? Mais em especial, hoje temos um mini curso promovido pelo Comitê de Poços, especial nosso Grupo Técnico de Completação, no qual temos o Vitor, o nosso chefe, que vai dar uma palavrinha para vocês em instantes. E sobre o nosso mini curso, nós vamos falar um pouco sobre Sand Control e suas principais soluções, que basicamente vai focar no desenvolvimento das telas de controle de areia, soluções como White Rapid Screens, que os nossos palestrantes vão falar ao decorrer da live, e do Inflow Control Device, uma tecnologia de bicos dissolvíveis e uma dissolução controlada por tempo, temperatura e salinidade, que vão ser temas abordados ao longo da nossa live aqui, desse webinar. Os certificados vão ser mandados ao longo da transmissão, então caso você esteja visualizando e participando, fique até o final da live, acompanhe para que possa garantir o seu certificado, e também as nossas redes sociais para que você possa acompanhar, se filiar ao SPE, e que possa estar mais perto das nossas atividades como os comitês técnicos. E então, sem mais delongas, vou chamar ao palco o Vitor Almeida, para falar um pouco desse minicurso, falar um pouco sobre o Grupo Técnico de Completação. Boa noite, Vitor.
Boa noite, Nicolas. Boa noite, ouvintes. Muito obrigado. Sejam bem-vindos à SPE Brasil Section. Nós estamos aqui trabalhando para que vocês possam ter um pouco mais de conhecimento e ter também um pouco mais de aprendizagem sobre as áreas, né, de atuação sobre completação de poços. Hoje o nosso tema, como o Nicolas já adiantou, é Sand Control, mas é um Sand Control associado com técnicas de AICD e ICDs, né? E é um tema muito interessante e acredito que todos vocês vão conseguir sanar algumas dúvidas sobre o tema e aprimorar muito os conhecimentos, ok? Os nossos palestrantes de hoje, o Mike e o Denis, eles são da empresa HP Screen, né? Eles estão localizados aí no Reino Unido, e a apresentação, por questões linguísticas dos participantes, será em inglês. Nós teremos aí um pouco mais de 1 hora de introdução desse tema e discussão do tema, e depois vamos abrir aí para algumas perguntas e respostas.
Pronto, perfeito, Vitor. As perguntas e respostas serão respondidas todas ao final, né, no decorrer da apresentação. E o nosso participante, como o Vitor bem falou, são o Mike e o Dennis, da HP Wells, né, baseado no Reino Unido. Vou convidar eles ao palco para apresentar. Lembrando, a apresentação será em inglês, mas nada impede que vocês façam as perguntas em português, nós traduzimos. Se tiver alguma dúvida da apresentação, a gente vai desenvolvendo. So, I will call Mike and Dennis to our virtual room. So, welcome, Mike and Dennis, to this webinar. You can present yourself.
Good evening, welcome, and my name is Dennis. I'm the Business Development Manager within HP Wellscreen.
Yes, good evening. My name is Mike Nieuwenhuis. I'm the Director with HP Wellscreen, looking after technology development and the commercial side of the business.
Okay, fine. So I'll put your presentation on the screen. So you can start, and the virtual stage is yours. So you can start the presentation.
Yeah. Well, good evening. Just to give you a small glance of the Netherlands, we have some nice tulips here in front of a drilling rig, drilling for geothermal heat, which is quite a big part in Europe these days for city heating. So just to give you a nice idea. What we will do, we will give you an introduction about HP Wellscreen, and after the introduction, we will tell you some technical details about the development of our erosion-resistant screens. And in addition to that, we will also tell you a bit about our dissolvable plugged nozzle technology, which is a combination with an ICD. Well, HP Wellscreen is a family-owned company active in the Netherlands and in Abu Dhabi. And in 1983, we started as Houston Wellscreen. After that has been sold, and in 1991, we have started HP Wellscreen as a private company, where HP stands for Hans Politics, which is the previous owner of the company. In 2012, we started our operations in Abu Dhabi, slotting and perforating, called Well Slot. So we have been active since then. And what we are aiming for in our meetings with clients is that we have face-to-face contact to understand the needs of the clients for their metal mesh screens or their wire wrap screens or inflow control. As you can see from the timeline, we have been active for over 40 years, so we have quite a bit of experience. And that's what we have gained all over the world, from Europe to Scandinavia, East Asia, South America, and some other regions. And for that, we supply to oil and gas industry and the geothermal industry. On the right side, you can see the brand or the markets we are in. So we're active in oil and gas, active in geothermal, we're active in general filtration, and a tiny bit in architecture, where roughly 70% is oil and gas related, 20% is geothermal, and the rest is general filtration and architecture.
Okay.
So this is how we started in 1983, being Houston Wellscreen, and then in 1991 and in 2012, you see the offices we are in right now. On the left, it's the Dutch office. On the right, it's the office in Abu Dhabi. So, what we will do, we will present you information about the erosion-resistant screens and the ICDs, which is a mixture of a general presentation we have, plus some presentations made with SPE in different regions. So you will see a mix of slides, and Mike will present you the basics.
please feel free to jump in with any question while we go ahead. Sorry?
Moet ik hem verder tikken straks?
Ik pak hem wel.
Okay.
All right. So, yeah, erosion and screen failure, which is a big issue in our industry. There's been many discussions around it. But all in all, it's causing a problem with that presenting a high cost where you have wells failing from erosion issues on your send control system. So we have been looking into solving this matter by looking at the failure mechanism of a send control screen and the reason why it's eroding. You have erosion, of course, in cased hole applications and in open hole completions, both with a different, let's say, method of erosion. But the erosion causes is mainly generated by holes in the base pipe. As you can see here, we have a screen section, and below, do you see a cursor? Do you see a pointer in this case? Do we have a pointer? No. Can somebody give me an answer here?
Is there a pointer in the system we can use, or is it just a cursor you can see?
We only can see the cursor. We don't can see the
You
laser.
see my cursor?
Okay,
Okay.
as long as you see the
All
cursor,
right.
it's okay.
Thank you. Yeah, so what we see here is a screen, wire-up screen, and just below we see the base pipe with a perforation. And same is in here is a metal mesh screen where the erosion starts around the holes in the base pipe. Yeah, and it is kind of logical as you get localized flow, and with localized flow we get an increase in velocity, and erosion is a function of velocity to the power 2.6, 2.65. Okay. This is an example of a North Sea operator, gas wells, high rate gas wells. Yeah, where you see, I showed you this picture before, but if you strip down the screen, you open it up, you see clearly marks and holes in the base pipe that are worn out. Yeah, and by this concentrated flow, we get an increase in velocities in the screen section, doing the damage. So we have been addressing these erosion issues. Yeah, where we have identified, let's say, velocities concentrated around the hole, yeah, and how to deal with that. We have come up with two different designs. The first design is a screen with a base pipe, yeah, for larger diameters, for open hole sections, let's say, where we are shielding off the hole in the base pipe, and by shielding off the hole in the base pipe, we are creating a flow path around the hole, and with that we are using more surface area, and by using more surface area, velocity comes down, and with that you have a lower erosion rate. The other screen design which we are offering these days, mainly in Asia, is a Thru-Tubing screen. Yeah, so for recompletions, let's say installing a screen in a cased hole application, passing mostly through a nipple profile. In this case, we remove the base pipe, so we have a base pipeless design, and by taking away the problematic area, yeah, we don't have this concentrated flow. we are using the full surface area of the screen. And again, with the higher surface area, velocity comes down and the erosion rate is reduced. Now, we went to quite an extensive development process, and with that we did extensive testing, both fluid, gas, in full scale, big setups. We have tested mainly coupons, 4-inch coupons, like I said, with different rates in fluid and in gas, accelerating the erosion, but still we wanted to identify where the what the cause of the erosion is. And what we have seen is that actually erosion is not from outside to inside, but it's mainly from inside to outside. Yeah, where I showed you the concentrated flow around this hole in the base pipe. Erosion really starts on the highest velocity, which is closest to the hole in that case, and then it's eating out outwards.
Yeah, it actually bounces back from the base pipe towards the screen.
Yeah. Okay. So with this designs and this testing, you would think we could easily harden a metal, and with that find ourselves a solution. That's correct, but it's not the full solution. In our case, we have been testing nitrating, boron, and diamond treated metals, both wire wrapped and weave. And indeed, this is something which we use, but with the combination of a pipeless design or the shielded design. We mainly use boron at this moment because it's the best balance between cost and performance. And what you can see here is let's say a square cut of tiny wires of a metal mesh screen, and you see nicely a 25 micron layer around the wires, meaning the outside is hardened. It's not a coating, it's really an infusion of the metal, but the wires still stay ductile, which we need, otherwise everything would break. There's no peeling or delamination. It's not a coating. It's the metal which is hardened. Okay, sorry. Where would this be put in? Let's say, to put this in a perspective, a normal screen 316L. Here we see the hardness of different materials, thickness. Where 316L is around 300 HV. Your formation sand lies around 1100, and in this case the harder material survives and the softer material wears out. Now tungsten carbide, which you might know, is around 1700, where the boron which we use is over 2000 HV. And depending on the material, the base material, 316L or 825, it even goes up to 2500 HV. And then the metal is not wearing out, then it's more the formation sand that is the weaker material. Okay. Like I said, this is not the final solution. From the testing, the hardening of a weave or a wire from a wire-up screen will provide you a factor of 2 extra in lifetime, let's say, which is directly linked to, let's say, weight loss from your erosion. So anything you do in mitigating these erosional issues is buying yourselves more time. Yes, you're extending the lifetime. But as soon as you are building up your sand layer, you are protected. Yeah, so it's actually a question of how much sand is there, how much sand is stopped, how much sand are we producing. Yeah, up till you have built a layer, you're protected. Yeah, so but in this case we are presenting an erosion factor, meaning it's the additional lifetime compared to a standard screen.
Yeah. And what you can see in the pictures on the top side, you can see the wear on the holes in the base pipe.
Yeah.
You see 5 dots, and on the lower part you see these dots are less, and this is with the hardened weave. So you see there's less erosion, and both are on the same timeline.
So this is from the testing, the lab testing with the coupons, 4-inch coupons, where we have used a base pipe, and this base pipe has 5 holes. Yeah, and then you clearly see this concentrated flow around the holes in the base pipe. This is resembling an open area of around, let's say, 7%, which is kind of a standard base pipe open area. Towards the pipeless design for Thru-Tubing applications, what do we do there? Like I mentioned, we will remove the base pipe. Can you do that? Yes, you can. This is a metal mesh screen, and a metal mesh screen has an outer and an inner shroud. If we increase the thickness of the outer and inner shroud, we are adding wall thickness. We are removing wall thickness here, strength, actual strength for installing and maybe pulling out, but also wall thickness for collapse and burst requirements. Yeah, so by increasing the thickness here and there, we are gaining a lot of strength. Yeah, and if you would look at the thicknesses are you in millimeters or in inches? I don't know. It's like how much are we there? 7 millimeter total what we could gain. Yeah, a pipeless design, again, I've mentioned it before, is used for Thru-Tubing applications. So these are the smaller diameters normally. Yeah. This is not to be used, of course, in a long horizontal section. Okay. Now this we have been testing as well. What do we see here? Weight loss again. In comparison with your standard base pipe, you have seen the holes on these test samples. Yeah, and measured here and presented here is the weight loss. And in this case, we are presenting the specific erosion. So that's the erosion against the amount of sand that is produced through the screen. And your normal screen would have, let's say, 23 grams per gram sand. This is to the power -6, of course. But if we compare the standard screen with the pipeless screen, yeah, including the hardened weave in this case, we are not at a factor of 2, but we are at a factor of 7 times better than your standard screen design. Yeah. And that's quite an achievement.
And that also comes because the open area with the base pipe is lower than the open area with just a screen. And then we have added the hardness from 300 to 1200 factors. And that combined makes the higher erosion factor.
Yeah. This testing was not with the boron, by the way. This was with nitrating. Okay, and the other solution, yeah, not Thru-Tubing, but let's say in case you would have an open hole completion, open annulus with the potential risk of annular flow with a high influx close to the heel, doing your erosional damage closest to the heel. You could think of doing gravel packing, but in case the gravel packing is not feasible or maybe not economical, you need something else, something that would fill the gap between a normal screen dealing with the higher flow rates. And we think this shielded screen could fill that gap. Again, a picture of concentrated flow, normal screen design. And in here we are introducing a shielded plate going over the perforation section, the hole in the base pipe. What it does, again, it's redirecting flow, and by redirecting flow, it's using more of the surface area of the screen. It's not just this side, but I will show you in a minute on CFD what we have done. It's using more surface area, and with that, again, velocity drops. How would that look in real life? A base pipe perforated section, and what you see here is our normal screen design, and below there we are introducing the shield, and in this case the shield is the blind section, and the blind section goes over the holes in the base pipe. Yeah, so influx is on this section, and then it will find its way around the shield underneath, finding its way to the hole. Somewhat similar pictures, which you have seen before from the testing. Shield in this case, and in here standard screen. Again, specific erosion, weight loss against the, let's say, produced scent. And in here, comparing the standard screen design with around 7% open area on the base pipe, again, we have a factor of 4 in favor of the shielded screen design. Now we have done CFD to also understand and maybe to show what's really happening in this case. We have mimicked the testing, the lab testing, full-scale testing. There's a big setup which we have used. We have mimicked that with CFD to see if there is an alignment between lab testing and CFD, and with that, if we could use CFD to predict erosion. The answer is yes. Here we clearly see the same pattern as on the lab testing, with the red presenting the highest velocities. Yeah, and now here in this area we have used the shield with the one hole below, but here you see a nicely distributed velocity, and this is what I meant with a more distributed flow using more surface area, which gives you a, let's say, a more moderate velocity. If you would take that into a square cut, what do we see here? Metal mesh screen, outer shroud, inner shroud. Yeah, this is your standard screen design compared to the shielded screen design. Again, outer shroud, inner shroud. Here we see on top, we see the drainage layer, and here we see a double, which is an overlay, a double weave, Dutch weave. Yeah. These red sections are the high velocities just above the holes in the base pipe. Yeah, where here you see a far lower velocity, and this is providing us the achievement in erosional strength. We've done here is we have linked the weight loss, erosion, or let's say modeling within CFD to the actual lab testing, and we see quite an how would say that
reduction in mass loss.
Yeah, but let's say the actual testing is providing the same outcome within CFD as the lab testing. So it's quite realistic what we achieve from the CFD. Yeah, you see the blue lines, the dotted and the straight line. The one is CFD and the other one is the lab testing. And again, you see somewhat the factor of 4 difference between the shielded screen design and the standard metal mesh screen. This was all focused on a specific screen, detail in where the erosion comes from. Of course, if you look into a standalone screen completion with annular flow rates and with an annular velocity, you also need to look at the full scale design of this screen. Yeah, so going away from the close-up of a disc, here we have modeled the full screen. Perforated base pipe, as you can see here, and here we have the shielded section and the perforated section. Now, over the screen length, this is the let's say the distance closest to the heel, but actually it's the first screen with the highest velocities. We see nicely a lower velocity influx, and with that, let's say with the lower velocities and then more even influx, yeah, it's helping to bring velocity down. If we take that into account in the actual reduction, erosional reduction, yeah, this velocity, this distribution over the screen section, using more of the screen section, yeah, would even go from 1.6 to 1.4. Sorry, from 1.4 to 1.6. Yeah, compared to comparing the shielded screen design with a normal screen design. Yeah, so again, comparing the screen, but comparing the completion, it's even functioning better. It's more like somewhat an ICD in a small area. Okay, this was the part on the 2 screen designs we are offering for standalone open hole and Thru-Tubing applications. And now I want to go on with something else, which is our plugged ICD, where we use dissolvable plug material to close ICDs
temporarily.
Yeah. Or we could stop if you have questions. We could first answer maybe the questions towards the screens and continue. It's up to you.
So we don't have any questions at the time, so you can continue the presentation as the questions will.
Okay, perfect.
Okay, fine.
Thank you. Our dissolvable plug technology. We got I think it's 10 years ago, we got some questions from out of Abu Dhabi, where they are drilling longer and longer wells, ERD completions, where they were facing quite some issues. Got a question that time from Satco, Exxon, if we would have done something in the direction of using small holes ICDs, where without any intervention we could open, let's say, the ICDs. And the answer was yes. We did some developments at that time in Germany, and we continued the discussions. And actually, with these long horizontal sections, they were facing issues in displacement of fluids, where, of course, you could solve this by using a wash pipe. But on these long sections, the wash pipe was the issue, as in weight, as in time, risks. Actually, they wanted to remove the wash pipe, be able to do displacement, place a breaker, open up the nozzles, and start either injection or production. So we came up with our DPNA, dissolvable plug nozzle assemblies, where we replaced what they call LEL, limited entry liner, with these nozzles, which is your standard nozzle, as in an ICD nozzle. But in this case, we plugged it off with dissolvable material. And now you could think that's easy, but it's not so easy. The dissolving part is simple. It's the part where it needs to stay closed for a long time. Yeah, so in 2018, we did some trial wells. This was quite a success. They drilled the fastest well ever, and on these rigs, they could save quite some time. We entered into quite an extensive testing program with Exxon, and came up with an, let's say, commercial design, where we are pushing the length of the liners further and further, and we are over 50,000 foot today. And as I said, it's quite a success. We have run quite some footage already over the time. And we see now not just the real long wells adapting to this technology, we also see some of the shorter wells that are benefiting from, let's say, quite a simple but a robust design. As mentioned, we have quite a track record with it, but we also did quite some development in this direction. Again, CFD, flow performance, integrity, all the erosion, which came along with this development. And yeah, the majority today is still run with ADNOC, but we are using this in the North Sea. West Africa at the moment, quite a lot. And I think in Brazil they have used something as well, but not the materials we are using. So what are we using? Like I mentioned, an ICD, a nozzle, small hole, which is filled, but we have 6 different grades which we work with, and we also have combinations of the different grades. And why would you need more grades? Well, not every well is the same, and with that, the fluids and the fluid programs are changing. Yeah, so we have materials that can dissolve in water, brine, oil-based mud, or acids. And the acid is the, let's say, the simple part. It's the other fluids, especially with the higher pressures and temperatures, which are the challenge, not just to dissolve, but to, let's say, maintain integrity for a longer time before opening up. Yeah, so this nozzle is actually a standard ICD, which could be used in an axial direction as well, or in a radial direction, in combination with your screen. Yeah, and here it's providing the same advantages. Yeah, you are eliminating the inner string, which again saving you time, cost, but also the risk that comes with it. You get a good cleanup, a good coverage, let's say recovery of your oil bismuths. It has quite some advantages. You could also think of a different way, not in long horizontal sections for ICDs. You could also, we have some wells now, quite some wells now in West Africa, where they have a somewhat slanted or more vertical sections, different layers, packers in between, and in this case, they want to pressure up the liner, set the packers, but then have selective production in between the packers. You could do this with sliding sleeves, of course, yeah, but a simple way and proven method now is to go with dissolvable plugs, where in this case quite some big ports are opening up. Yeah, so in this case we are not introducing an ICD function. We are introducing big plugs, providing quite an open area in a short joint. And again, it works the same. Yeah, same materials which are used here. Okay, just a slide which maybe we should have put up on the other with the screen part. With the screens and erosion, we also can offer you. We have the model for the wellbore modeling, and to look at the erosional strength. And with that, we and the data we have gathered from all of this testing, we can provide you somewhat with the mean time to failure in both cases. Sorry, this was mixed up with the
erosion resistant screens.
Okay. Yeah, these were the slides we wanted to show you. I don't know what time we have now. 10 to 12. I hope there's some room for questions. If there is any, please shoot.
At the moment, we don't have questions in the chat, so I will ask for the people to show some questions. Pessoal, caso tenha alguma dúvida no chat, pode mandar, a gente traduz de português para inglês ou inglês para português, para que o webinar seja mais vívido, não seja um monólogo. Vou chamar também o Victor ao palco para que ele possa contribuir com insights, ideias. So I will call Victor to the stage to talk about this webinar, to show some insights, ideas. So, pronto, chamei o Victor, ele está se conectando daqui a pouco para que a gente possa...
Oi, me escuta?
Escuta, sim.
Opa, beleza. Eu tirei a câmera aqui. Thank you so much. I am very impressed. First, my first express is very nice, right? I am very impressed with the parts that you show us, showing the lab test structure of your company, right? It's very nice, and for me it's important because you transmit you transmit more comfortable to the people that are assisting us, right? My first point is all tests and lab tests that you perform in your structure is inside your your company or your
No, this was
or third part?
Third party. All the testing we have done is third party. For the erosion testing, we use tri-diagonal set up in the US and in India. They have quite a large setup, which is used by more operators, let's say.
And normally you study the regions, the case that you can apply your product, or how you define the product that you will release or think in the industry?
Yeah, in this case, it's not that we didn't know where the problem on erosion was. If you would have pulled screens from the well, and we have, you can clearly see patterns of, let's say, a perforation pattern, which is indicating that it is a concentrated flow. So then you start thinking how to deal with that. So you try some things, and of course, it's not that you find the solution the first time. So this testing, what I've showed you, is a 3 years time.
Yeah.
It's not a month. It's quite some time.
In case that one company has a specific or particular problem, your company can study and develop one product.
This is what we do. Yeah. We are more flexible and smaller than the big guys. Of course, they have quite some engineers, but we can make a decision to move in a direction to find some solutions, to do some development and validation testing quite quick. If we see an opportunity, everything is with an opportunity.
And based on that, we can also custom build when there is specific requirements for the client. And that's when we like to sit with the engineers, understand what problems they are facing and they cannot get from the market, and then see if we can be of support by building it as a custom fit product.
And validate by testing.
We have our first question from our public today, right? Nicholas, you read or?
I can read. So the question is from Erica Carolina. Erica is with me in the technical committees. So Erica say, let me see. Okay, consider the increasing challenge of sand production in mature fields, such as erosion resistant screen technology, ERST, and inflow control device, ICDs. With Dissolvable Nozzle technology, is the theme of this webinar. How can deployment be optimized for different reservoir conditions to maximize productivity and well longevity?
Can you show the last part as well?
Okay.
After how can deployment be optimized for different reservoir conditions?
Yes.
Okay. Yeah, of course, if you have a mature field and if sand problems are coming with the maturing, let's say, you have to do something. And this could be by remedial sand control. But in that case, of course, if you have an open hole, carbonate, and or let's say not carbonate, but an open hole, where you can introduce a screen, but most of the time it's a cased hole, perforated cased hole situation, and then you get challenges how to install a screen in a cased hole application. This is providing you most of the time erosion or headaches, and then a screen which we have shown today could provide you a somewhat longer lifetime. Is that always the cure? Yeah, it could be, but it can also be that you are producing for half a year, and then the screen is gone. Also, it's a good screen. Yeah, it's still a half a year. We have seen that in the North Sea over here, production of half a year, and everybody's happy. Yeah, but then sand is still coming. It's eroded. So the designs which you come up with, you need to think about retrieval. Get the screen out of the ground, out of the well in full, not that it breaks, because then you can run a new screen and continue. Yeah, that could be a modus for all the wells where you cannot spend too much money, but still with a simple method of installing an erosion-resistant Thru-Tubing screen and extend the lifetime of your well. And this is what we have seen a lot on gas, but also oil wells in Europe. Yeah, but the trick is, of course, what we are presenting erosion resistance, or let's say pipeless design, which is not new. We are using that already for 40 years. Yeah, we know what it does, but we took it along with the testing program to show the effect of a pipeless design. Yeah, but the actual trick in this case is retrieving the screen and continue producing from the well.
Yeah, what we see in the Netherlands and North Sea is that you have aerated gas wells where sand is produced over time and the service equipment is getting eroded. So to protect the service equipment, they run down a Thru-Tubing screen, set it in a nipple profile, and like Mike said, it's 6 months or 12 months depending on the well. And then after that, they pick it up again with wireline, put back a new one, and are protected for a longer period again, which is way more efficient than having a full workover on the well.
And the other thing we see is, let's say in Norway, more expensive wells with, let's say, gravel-packed zones, sliding sleeves, where gravel is produced. We see that now more and more. It could be that some of the zones are still producing. Yeah, some other zones are closed off, not contributing anymore. But they want to continue with these wells. And they need to, well, they cannot just produce of the erosion to the flow lines like Dennis is mentioning. And then we are placing maybe a straddle in front of the sliding sleeve, or reperforating a section, or placing a screen just above the producing section, just to continue production. Yeah, but again, in this case, it was gravel coming back.
Yeah.
And with that sand, we see that a lot these days.
Okay, fine.
High producers in the North Sea, let's say.
Yeah, based in your answer, here in Brazil is more common use nipple profiles 3.5 and normally 2.75 inch, right?
Yeah.
There is any limitation for OD that you recommend for use or not?
That is a good question. And I like to... Zeg je?
Nee, het gaat goed zo.
Gaat goed zo? Yeah. Sorry for the Dutch. Where is it? I need to go back.
Yeah.
And I don't know. Oh, maybe it's here. Yeah, this is quicker. Sorry, now I know how it works. Where are we?
Nou, vanaf 10 of 11 zit.
10 of 11?
Ja, begin.
Die?
Even kijken, wat zoek je?
Here.
Yeah.
Okay. Standard screen, of course, we have a diameter of the waste pipe where the screen is built over that OD where you are fixed. In this case, we have full flexibility. We can build any diameter. if we skip the base pack. We just manufacture the shrouds towards a specific size. And in that case, if we need a 2.44 inch OD, we will build a 2.44 inch OD of whatever nipple profile you have, where you're confident, let's say with a, what is it, an 1/8 of an inch, or a 1/8, or maybe a 1/4 inch clearance to pass the nipple profile. Yeah, so any diameter from 1 inch approximately. Yeah.
Yeah. Okay.
This goes up to maybe 3.5 inch maximum in diameter.
Okay. Other question is for me, right? Is not much clear. Which situation you recommend use ICDs, right? Thinking in the wells.
ICDs, you could link that to erosion, but ICDs, of course, is in the first application is to get a contribution over the complete horizontal section of your producing zone, horizontal section. In case you have drilled, if you are drilling longer wells, overcoming the differential pressure of this length, or and we don't do that much anymore, you could compensate for the difference in permeability from your reservoir. But in that case, you need to be kind of specific in getting the right sections at the right spot. If you do a design, ICD design, compensating for permeabilities, and if you do not get to TD, you have a mess. Yeah, so we don't see that much anymore. Then it's more to get an even inflow profile over the complete horizontal section. This can be inflow, this can be outflow. Yeah? We do a lot of outflow as well to have stimulation, matrix stimulation of the entire well. And then, of course, if we look at erosion in, again, if we have an open annulus or a gradial field formation with some open sections, you get annular flow. If we introduce ICDs in that case, we are limiting the annular flow because we get an entry over the horizontal section. We are reducing the volume, the flow in the annular section, and with that we are reducing the velocity at the first screen. Yeah. So if you combine the shielded screen with ICDs, that's the best solution you could get comparing with let's say with the Graphopack. Graphopack overwins, but anything below is an ICD completion with a shielded screen.
Yeah, sorry. Sometimes I know some things, but I need to help our public to think difference, right?
Sure.
The other point is I can consider ICDs and ICDs the same product. There is any difference that you can explain more for us? And thinking in this, what is the expectation that we have to really reduce the volume of water produced, right?
What produced water, you mean?
Yeah.
The of course an ICD is a nozzle, and with that is introducing a DP, overcoming a differential pressure lost from a length. With that, if you look at reduction in water production, it's only delaying. Yeah, if we get an even inflow profile, if we have a water-oil contact somewhere, you get a breakthrough. By, let's say, distributing your differential pressure over the full length, we are delaying this breakthrough. Now, once you have the breakthrough, it doesn't stop it. Water will come from the mobility ratio, more water will come and you will produce less oil. An AICD, autonomous valve, depending on the type of valve you have in front of you, let's say the TACA design or whatever, the or Inflow design, which is our partner. It's either choking back, reducing water or gas production, or completely stopping, let's say, water or gas production from a specific zone. So once you get a breakthrough, an autonomous device would really lower or stop water or gas production. An ICD cannot do that. That's the difference.
Okay.
The valve will just shut off a section, and an ICD will always be open.
Yeah. About the area, you talk a lot about the horizontal well, right? But for deviation well with a short pay zone, let's suppose a 50 feet, what is the difference that we need to think in drainage area to choose a better product to use in field? Is based only in water production, right? Let's suppose that we have a high BSW, right? Or other point that you can inform us how you can design, how you can design or how you can project the one send control in one situation that we have a high BSW, thinking in drainage area with short pay zone.
Yeah, is that linked again to high velocities in that case? Are you thinking of erosional issues? It all depends, of course. At what point is the velocity too high? Yes, at shorter sections, even in the short sections, you could have the top or bottom producing all of it. If this formation is, let's say, failing and would form itself around the screen, you don't have any erosional problems. But in the case your formation is somewhat heterogeneous and you're not able to, let's say, select the right pore size. In that case, you would be producing a sense where, yes, you have to think of maybe protecting yourself with a more erosion resistance in terms of screen selection. In other, it could also be that your formation is somewhat, bimodal, and fine sense is continuously produced through the matrix from this higher flow rates in the vertical section, that you are also continuous producing scent. Yeah? And also in that case, you need to think of a screen design. But in all other cases, when you're stopping sand, there is no risk, in my opinion. As long as there is no sand produced, erosion is not there.
Okay.
Does that answer the question, or did you mention something else?
Yeah. Dennis, Mike, thank you so much for this opportunity to show you your product and your expertise in sand control. My last question for you, before pass the final words to Nicholas, is how we can find HP well screen here in Brazil, and how we can contact you in case of doubts or thinking featured products.
Yeah, well, we work together with Ricardo Nunes. He's our local representative in Brazil. He can guide you through, and especially on the Brazilian on the language, we are not that familiar with that part. So our English is good and our Dutch is pretty good, but our Brazilian is not that good. Portuguese, yeah. So it's either through our website, and then we will link in with Ricardo as well. I think that would be the best way. So sales@hpwellscreen.com, and then through there we will connect you.
But I assume they have our email addresses in this case. Yeah.
Or you contact us through the SPE.
We have been attending the SPE show the year before, I think.
Yeah, 2 years ago.
2 years ago. So if there is interest from your side, we will sure be back and be visiting the local show.
And if there's a lot of interest, we can always plan a meeting local in Brazil, and then do a local presentation for a bigger team.
We are happy to come over. We are traveling a lot.
Okay, thank you so much, Nicholas.
Okay, fine. So thank you, Mark. Thank you, Dennis, for this presentation. I think that's a lot of sides, a lot of knowledge to our public in YouTube. So now, changing Portuguese. Pessoal, obrigado a todos que nos assistiram. O certificado foi enviado pelo chat aí do YouTube. Perguntas, comentários, entre no nosso grupo do WhatsApp do CT de Poços, para que nós possamos interagir melhor, tirar insights, trocar conhecimento. Também nos sigam nas nossas redes sociais, o Comitê Técnico de Poços tem uma página dedicada onde a gente divulga os eventos, webinars, minicursos. Também siga a nossa página do Comitê Técnico, da diretoria, como também a SP Brasil, em todas as redes sociais, né? Seja membro, caso você que esteja assistindo não seja. E no mais é isso, obrigado pela presença de todos. Vitor, mais alguma consideração final? Pode ficar à vontade.
Não, só agradecer a todos, e a gente está sempre fazendo esses encontros, né? E vamos procurar nos próximos meses trazer outro tema bastante relevante para todos.
Perfeito. So, thank you again, Mark and Dennis. See you next time.
Thank you for the opportunity.
Thank you. This transmission is over now.
Bye.
Bye. Good evening. Bye-bye.
Bye-bye.